Honey.
This is plus 4.
Why? Okay.
12 divided by 3 equals 4 instead of negative 4.
Wow. Okay. So your goal, okay, remember yesterday we were learning about absolute extrema. Your goal is to find absolute extrema on negative 1 to 8 for this function. So the first thing that we do is take the derivative, but in order to take the derivative, we need to rewrite this term. So if it's a cubic root and it's squared, you're going to have to use a fraction. Okay, so we're going to rewrite, remember this is not a derivative, 2x minus 3, and then when I get to that x part, remember it goes power over root. Okay, so what would I put? 2/3. And the reason that I'm doing that is that I want to be able to take the derivative easily. Okay, so this is y. Now let's do y prime. What's the derivative of 2x? 2 minus. Then I'm going to take the 2/3 and I'm going to multiply it by 3. What is 2 times 3 on top?
6.
6 divided by 3? 2. Could you also have just noticed that these 3's would cross out? Sure. If you saw that, that's great. Okay, now my x was to the 2/3, but I need to take away 3/3 because that's 1. Negative 1/3. Good. And if it's a negative 1/3, where does that really go? On the bottom. So I have 2 minus 2 over the cubic root of x. So far, so good? Okay, that should look familiar. That just happened, right? You can't have two separate fractions. You got to get it all together. So we're going to common denominatorize it. Okay, pretend that's a word, but it's not. Okay, so I'm going to put a cubic root x here so that they match, but I can't only put it on the bottom. I have to also put it on the top. So I'm going to put a cubic root x up here as well. Now, do the bottoms match? Then I can write it as one fraction. So across the top, I'm going to have all of this. And then on the bottom, I'm just going to put that same denominator because they matched. So it would be 2 cubic root x minus 2 over cubic root x. Okay, any questions to there? No, okay. Next, we want to look for anything we can factor. Is there anything we can take out of the top? Okay, so they both do have a cubic root, but we're just going to try to factor off the top. Because remember, and actually I see a lot of y'all do this sometimes on homework, and I don't know if it's just because you know that I grade at completion or because you don't know you can't do it. You can't cross those out. Yeah, I know, but sometimes I see y'all do that, and I wonder if it's just because you're trying to just write stuff down. Okay, but you could only cancel these if you could GCF it out and then cross it out. That would be legal, okay, but canceling here, illegal. Okay, so I'm going to take my 2 out, and then on top I'd have a cubic root x minus 1 over cubic root x. Okay, we're looking for our critical numbers. Remember, critical numbers are anything that make the top or the bottom 0. Let's do the bottom first. What number, if I put it in that root, would give me a 0 on the bottom? 0. Okay, so critical numbers, x equals 0. That's the one that came off the bottom. Now let's do the one on the top. What number, if I cubic rooted it, and then minus 1, would give me 0?
1.
1. If you don't know where that came from, just solve it by hand. Look. Cubic root x minus 1 equals 0. What would I do? Add the 1 across. And then what? Cube it. And then the cube root would go away. And what's 1 cubed? 1. Okay, so you would cube, and get 1 for your other answer. So if you need to do it algebraically, that's always okay. But if you can just see it, 1 is the other number. Okay, set up your number line. 0 and 1 are our critical numbers. On the bottom, we're going to label it f prime. On the top, we're going to label it f. Okay? So let's pick a number smaller than 0. Say we pick negative 1. Okay? We're plugging in on the top first. What is the cubic root of negative 1? Still negative 1. Minus 1 more.
0.
Negative 1 minus 1 more would be negative 2, but remember, we don't even care about the number, we just care that it's negative. Okay, on the bottom, I have a negative number and I cube root it. The bottom is also negative. Divide two negatives, what do you get? Positive. Okay? Next we're doing, let's say, a half. Okay? What is the cubic root of a half? Is it bigger or smaller than 1? Smaller than 1. If I take away 1, then what's the sign going to be? Negative on top. But what's the cubic root of a half? Positive. So I'd have negative stuff on top because I had to subtract. And then I have positive stuff on the bottom. What's the overall sign? Negative. Okay, then let's pick something bigger than 1 that has a perfect cubic root. Let's pick 8. Cubic root of 8 is 2. What's 2 minus 1? Positive. Okay, plug in 8 down here. Cubic root of 8 is positive 2. Divide two positives, you get a positive. Which means my sign chart tells me it's plus minus plus for f prime. What does that tell us about f?
It's going to be max and then min.
Okay, yeah, so remember your words would be increasing, then decreasing, then increasing. And then we would label our relative extrema right after that. So I would have a relative max at x equals 0. I would have a relative min at x equals 1. So if you end up with separate fractions, then you have to be able to do that common denominator stuff. Okay? Do we want to do one more of those, or do you guys feel like you're good?
We're good.
Okay. Anybody else want to do one more?
What?
Huh?
We're doing absolute though?
Oh, F, yeah.
Oh,
Sorry, Valerie! Okay, these are relative. What do we do to make it absolute? Compare what? The endpoints. So remember, you have to do your candidates chart. Okay, so X, Y. Okay, remember, what goes in the test are the endpoints and then the relative extrema.
Maybe 1 and 8 because we don't need 0.
That, why do we not need 0?
Oh, it's negative 1? Okay.
Yeah. So negative 1 and 8 are my endpoints. 0 and 1 are my extrema. Now, what are we plugging into?
The original.
The original. So I'm going to rewrite it over here. Y equals, it's 2x minus 3 cubic root x squared. Now, let's start with 8 because it's a perfect cubic root. Ready? So I'm going to go bottom up. Okay, so I'd have 2 times 8.
16.
Okay, 16 minus 3. And then this is the cubic root of 8 squared. Okay, let's go one thing at a time. Always go small before you go big. What's the cubic root of 8? 2. Square it. 4 times by 3?
12.
What is 16 minus 12? 4. Okay, now let's go with 1. Ready? 2 times 1 is 2 minus 3 times the cubic root of 1 squared. But what's the cubic root of 1? 1. Square it. Still 1 times by 3? 3. What's 2 minus 3?
1.
Good. Negative 1. Okay, next we're plugging in 0. What would we get? 0 minus 0 is 0. Next we're plugging in negative 1. 2 times negative 1 is negative 2. Minus 3, and then this is the cubic root of negative 1 squared. What's the cubic root of negative 1? Still negative 1, but now square it. Now it's a positive 1. So I'd have negative 2 minus 3 more. What's that? Negative 5. And then out of those choices, you have to pick the absolute biggest y value and the absolute smallest y value, and those are your winners. What's my absolute max? 4. Where does it happen at? 8. So my absolute max is 4 at x equals 8. What is my absolute min? Min is negative 5 at x equals negative 1. Good. Okay. I know, but you wrote kind of big, you know? So, don't be too dramatic. I know, because I write huge, though. Because if I try to, like, squeeze right, then people are like, what does that say? You know? Hate that. But if you can't see it, obviously ask me. But that's why I write really big. Okay, so are we good?
Yes.
Okay, so we are going to learn next week the second derivative test, and it is shockingly similar to the first derivative test. So our quiz this week is only going to be on related rates, which is why you should have picked up this sheet. Okay, the entire first page is first derivative test stuff, so we're going to skip that, and we're going to go to the second page, which is a review of related rates. There are 5 examples. We're going to do all 5. And then if we have extra time, depending on how well it goes, then you guys will have time to work on your homework.
Wait, so we don't
Okay.
have to turn it in by tomorrow?
You are not turning this in tomorrow. We're doing all of it in class. We'll do the first page on Monday as a warm-up before we learn second derivative test. Okay?
Okay.
Wait, what are we doing? I was so confused with what paper.
Did you pick it up on the way in? You did? Okay, so it's this, and then you turn to the turn what you have in your hand over. Yep, right there.
That's the third.
Oh, okay. I meant like the front of the second page. Okay. So the plan is tomorrow your quiz is only over related rates. We will do the first page of this on Monday. Don't do it for homework, okay, or else you'll be bored. Okay, so look at number 1, okay, and I want you to do your find given when. Notice they gave you the picture of the triangle, okay, so you don't have to draw your own. Okay, somebody tell me one thing that we know. Find given when or the equation. Well, actually, don't tell me the equation, but out of the first 3. What are we finding? Okay, we're finding dx dt. Okay, what were we given? Good, it says theta increases, so we know d theta dt is positive. Okay, specifically it's positive 3. Okay, what is our when?
3.
When x equals 3. Very good. Okay, so looking at my triangle, I know about this side, and I know about this side. So if I want to choose those 2 sides, think about your SOHCAHTOA. Here's theta. Okay, what side is this out of the hypotenuse, opposite, adjacent? This is the adjacent side because it's touching the angle. Okay, then this would be the opposite side, and this would be the hypotenuse. Okay, so if I want to include the opposite and the hypotenuse, which trig am I going to pick? Sine. Sine theta equals, what's my opposite side? X over 5. Questions about how we picked that? Okay, you do not want to do quotient rule ever unless you have to. So how can I get rid of that 5?
Bring it to the other side.
Okay, bring it up here. So I'll have 5 sine theta equals x. Okay, we're ready to take the derivative now. What is the derivative of 5 sine theta? 5 cosine theta equals
Oh, dx.
d theta dt. You guys all forgot it.
Oh,
Okay, and then what's the derivative of x? dx dt, good. Okay, so remember, whatever letter you have, unless it's a t, it leaves behind a rate. Okay, from here, I do not know cosine, but I know the sides of the triangle. It told me that this side is 3, and if this side is 3 and this side is 5, what side goes with that? 4. So if I want to know what cosine is, what side ratio is that? Adjacent over hypotenuse. What's the adjacent side to our angle? 4. What's our hypotenuse? 5. So I would have 5 times 4 over 5. Okay, and then what's my d theta dt that was given? 3 equals dx dt. Easiest problem ever. Okay, then what happens with the 5s? Cancel out. 4 times 3? 12. Answer E. Okay? One is a free response. It has a part A, B, and C, and then on the back there are 2 multiple choice. It's pretty short because it's Rams. It is a free response with 3 parts and then 2 multiple choice, and they're all AP questions.
Oh my god.
That's good.
So like, if you bomb one, you're gonna
Okay. I mean, I'll grade based on like partial credit, so it's not like you just get like it wrong and you lose. You know. Okay, next one. I was thinking y'all were like, yeah, short quiz.
No, that means they count.
Okay, all right, fair enough. Valid complaint, but I'll grade your work. So, yeah. All right, read through it, fill it out, and notice again they give you a lovely picture to use, so you don't have to draw your own. Okay. Leave the equation out for now. Find given when. What do we know?
We're finding
Okay. Good job. Finding dx dt. What were we given? Okay. dz dt is 1.
dx is when you multiply 3.
And dx dt is 3 dy dt, which is kind of weird. Okay, but just write it down. So we know whatever dx dt is, it's triple whatever dy dt is. Okay, then it says at the instant when. Okay, now you guys are smart. You know your Pythagorean triples. If 2 of the sides are 3 and 4, what's the other side? Z is 5. Very good. Okay, so what equation should we use if we know about the sides of a right triangle? Pythagorean theorem. Okay, go ahead and set up your equation and take your derivative. Okay, which side has to be the hypotenuse in the equation? Z. So it would be x squared plus y squared is z squared. Okay, we're taking the derivative. Okay, what's the derivative of x squared?
2x dx
Dx dt plus
2y dy
dy dt and? This is how y'all study groups are, I bet. Say everything in perfect harmony. Okay, then from there we're plugging stuff in. 2x, what's x? 2 times 4. And then dx dt, remember we have this weird substitute. Okay, just go with it. We're going to plug it in. 3 dy dt. We don't know what we're doing with it, but it'll be fine. Plus. Okay, 2y, what's y? 2 times 3, and then dy dt, we do not know. Okay, going to the other side. 2z, what did we find z was? 5, and then what was dz dt? 1. Okay, let's kind of combine some stuff together. So look at your first term. I have 2 times 4 times 3. 24 dy dt. Plus, next one, I have 2 times 3. 6. And do you notice that they're both dy dt's? That makes them like terms with each other.
30 dy dt.
So all together, if I have 24 dy dt's and then 6 more, that means really I have 30 dy dt. What do I have on the other side equal to that? 2 times 5 is 10, times 1 is 10 again. Okay, what's dy dt then? 1/3. Good job. Okay, so I get 10 out of 30. That can reduce to 1/3. And then am I going to pick answer A? Thank you.
Can you post it?
I will, I'll post it.
Thanks.
Okay, say what you're about to say. Yes. Okay, this is dy dt is 1/3. But it asked me for dx dt, so answer A is to trick you. Okay, if we want dx dt, remember that's triple dy dt. And if dy dt is a third, then what's 3 times a third? 1. Good. Alright? Alright, turn the page. Okay, next one. Try to label what you can. Remember, anything that is not changing, you can put a number in for. Anything that is changing, you have to use a letter. Okay, what can we label so far? Okay, what's d theta dt? Okay, the theta is increasing at 1/5, so that's d theta dt is 1 over 5. Okay, we want to find out what rate is the shadow changing. The shadow here is labeled as x, so we're finding dx dt. Okay, the when... Yeah, when the shadow is 60. So that would be x is 60. Now let's talk about the 80. Is the building's height changing? No. And I can just call that 80. Okay, that side is always 80. It's not changing, so I'm not going to pretend like it is. Okay, so think about the sides of your triangle. Okay, here's my theta drawn in for you. X is adjacent to the angle. 80 is opposite the angle. This is the hypotenuse. Which side do we want to know about? The adjacent. Which one do we know stuff about? The opposite. So if I want to pick those two sides, we need to use tangent. Tan theta equals, my opposite side is 80, my adjacent side is x. Now, if I'm going to take a derivative, remember, anything but quotient rule. Do I want to times the x over here? Okay, you could, but you'd have to do product rule. So instead, we should rewrite. How can we rewrite this x and bring it up? Good, so I'd have tan theta equals 80x to the negative 1. And then now I'm going to take the derivative. Okay, so ready? What's the derivative of tan theta? Ooh, good. Okay, secant squared theta, d theta dt. And then on the other side, when I do the derivative here, I'm going to have to take my negative 1, multiply it down on the 80. What's that? Negative 80. And then if x was to the minus 1 and I minus 1 more, now it's minus 2. So instead of writing that, I'm going to put over x squared. Okay, am I done? No. What do I need to put? dx dt. Okay, remember that needs to go on that other side. Now, when you get to this point, in order for me to evaluate secant, unless I know what theta is, I got to use the sides of the triangle. This side, it says, is 60. This side is 80. 3, 4, 5, if you double it, is 6, 8, 10. So if this is 60 and this is 80, what does this side have to be? 100. Now, if you didn't know that, could you do Pythagorean theorem to find it? Yes. Okay. So if I want to fill in secant in my equation, okay, remember that cosine is adjacent over hypotenuse, and secant and cosine are just flipped of each other. So what will I plug in for secant in terms of my sides? Backwards for secant, it'd be 100 over 60. Good? Okay, 100 over 60. Okay? That's okay. Y'all are doing great. And then it's squared. And then I have a d theta dt. What was that? A fifth. Okay, moving to the other side now. I had a negative 80 on top. What is my x if I square it? 60 squared. Actually, I'm just going to write it like that. Okay, and then dx dt. Now think about, if I want dx dt by itself and I have a fraction in the front, how do I get rid of it? Reciprocal it on the other side. So I'm just going to put dx dt equals, I would have the 100 over 60 squared. I'm going to square both of those separately, times the 1/5, so that's just this side. But then this side, remember, I have to flip. So I'm going to have a 60 squared on top, a negative 80 on bottom. Okay, and all of these are multiplied. So do y'all see where everything ended up? Okay, this blue stuff stayed exactly the same, but the yellow thing flipped to go to the other side. What's going to cross out?
The 60 squared.
Good, the 60s are going to cross out, so this one's gone, this one's gone. Okay, then I have 100 squared over 80 times 5. What's 80 times 5?
400.
So I'd have 100 times 100 over negative 400. What could you do from there? You could cross out some zeros, but what's 100 and negative 400 if you reduce?
1/4.
Negative 1/4. And what's 100 divided by 4?
With the 25.
Negative 25. Now, could you, though, have left it like this and been done? Yes. You didn't even have to cross out the 60s if it's free response. Okay, probably will they make you do that much? Probably not. Okay, but you should be able to, if it's multiple choice, try to work it down at least pretty close. Okay? Huh? That would be in feet per minute, yes. Okay? Alright. Now, the next one, you need to draw a picture because I made it up. Okay? And it's very it-inspired. Okay? Okay, you have a balloon rising. Just kidding. Okay, you have a balloon. It says it's rising vertically at a rate of 2 feet per second. Just when the balloon is 29 feet above the ground, a bicycle moving at a constant rate of 4 feet per second passes under it. So our bicycle's here, but remember, he's moving, okay, this way, so I'm going to draw him over here, so he's not directly under it. Okay, there's the, he has a bell on his bike. Okay, there he is, biking along. Okay, there he goes. So, we have two things that are moving. We have a guy moving, let's call it X. We have a balloon going up, let's call it Y. Question A says, how fast is the distance between the bicycle and the balloon changing? Remember, distance is always a straight line. You have a triangle. Okay, let's label some stuff. Find, given, when, equation. Okay, and then buzzkill, we know this is going to be x squared, y squared, and d squared. D for distance.
All the sides, or next looking for the sides to use.
Yes. Okay, so the balloon is rising at a rate of 2. What is that?
dy
dy dt. My balloon is going up at 2 feet per second. My bicycle is moving at a rate of 4 feet per second. What would that be? Okay, dx dt is 4. Okay, and then we want to know how fast the distance between them is changing. What is that?
dt.
Yes. Where d is the distance. Okay, that would be the hypotenuse side of your triangle. Okay, from here, my when. These are a little bit harder. You have to kind of think outside the box. Let's talk about our bike first. How fast is the bicyclist going, it says? 4. Okay, he's going 4 feet per second. We want to do 3 seconds later. Okay, so think about, he goes 4 feet per second for 3 seconds. He would have gone 12, so x is 12. Okay, does that make sense? He's going 4 feet per second. We have to wait 3 seconds. You'd have to multiply. Okay, let's talk about the balloon. How fast is the balloon going up?
2. So
2. How long do we have to wait? 3 seconds. So if he goes 2 feet per second for 3 seconds, how far did the balloon go? 6. Now think about, where did the balloon start? 29. So if it was at 29 and it went up 6 more, where is it? 35. Now, if we know x and y, can we go back and find the other side? Okay, this is not going to be like a normal triple I'd expect you to know. So, who has a calculator that will do it? Maya does. Great. And it should be a whole number. Okay, 37. Okay, but remember, we weren't given it, but we could do it. Okay, from here, let's take the derivative. Okay, what's the derivative of x squared?
2x dx.
Okay, y squared? 2y dy dt?
2d
Yes. Okay, then from there, you would plug stuff in, get your answer to the end. Okay, so what is 2x? Okay, 2 times 12. Then dx dt was 4 plus 2 times y is 35. dy dt was 2. And then 2 times d was 37. We had to find that. And then dd dt. What I would recommend when you put this in your calculator is I would type in literally this entire line, figure out what it is, and then divide it by 2 times 37. Now, when you divide that in your calculator, what will you need to put around it? Parentheses. Okay, you could do that if you had a calculator, but most of you I see don't, and we have about 10 minutes to do part B. Oh, are you doing it?
Is it supposed to be a whole number?
No, it's a fraction.
Okay,
17.459. And that would be how fast the distance is changing. Now, does it make sense that we would get a positive number? Because what's happening to the distance between the balloon and the guy? It's increasing, it's getting longer, okay? That would be in feet per second, yeah. Okay, part B. We have a girl playing on the playground. Okay, there she is. Okay, and she is watching the balloon from afar. Okay, there it goes, up in the air. Okay, then it says, what is the rate of change of the angle of elevation for the girl looking at the balloon? So she's looking up, boom, triangle. Now, let's label some things in our picture. How far away is the girl from the balloon? You have to read it.
A girl is playing playground 30 feet away.
Okay, and look, it says the girl is standing, right? So we don't have to worry about her moving, so that 30 is fixed. Okay, then it says the balloon is 40 feet in the air. Okay, is it always 40 feet in the air? No, that's going to be my when. Okay, then we want to know about the angle that she's looking at the balloon from. Label your theta. Find given when equation. And I think I said this, but the AP test will give you these pictures. So if that part is confusing to you, don't worry about that. They always will give you a diagram or something. Okay, they did give us y. What is y? 40. And then we know how fast the balloon is going up from the other part. dy dt is 2. We are finding d theta dt. Now you have to pick your equation. Don't say it out loud. Okay, think about the side that you know stuff about and the side that you want to know stuff about, and then think about your SOHCAHTOA. Which one would we pick here? Tangent. Good. Tan theta equals opposite over adjacent would be y over 30. Can we eliminate the fraction?
Yeah.
Okay, take that 30, whoop, put it right there. So you'd have 30 tan theta equals y. Take the derivative. Okay, don't say it out loud. And then you're going to have to use the stuff that you know to plug stuff in. What's the derivative of 30 tan theta?
30 secant squared theta.
Good. 30 secant squared theta, d theta dt. What's the derivative of y? dy dt. Okay, and then when I get to this secant chunk, you're going to have to use the sides of the triangle. Problem is, we only know two sides. This is 30, this is 40. But using your triples, if 30 and 40 go together, what's the other side? 50. And so if I want secant, remember that secant is cosine upside down. So if cosine's adjacent over hypotenuse, then secant is hypotenuse over adjacent. So what is the hypotenuse? 50. What is the adjacent? 30. Squared d theta dt. What is dy dt on the other side? 2. And then if I want to get rid of all of this fraction stuff, remember, you just need to flip it and put it on the other side. So d theta dt would be 2 times, and then I would flip this. So my 30 squared is on top, my 50 squared is on bottom, and then this extra 30, think about it, it's like 30 over 1, so now it's 1 over 30. And then I would look to see if anything can cross out. Okay, if I have a 30 squared on top and a 30 on bottom, what's going to happen?
30 over 50.
Okay, the 30 is going to have to stay. What's 30 times 2 on top? 60 over 50 squared. Okay? And that would be good enough. If you did have to work it out further, this is what I would recommend. So if you get it to here, good. What I would think of is this is 50 twice on the bottom, yeah? You can only cross out a 0 on top if you cross one off on bottom. So you could make that 6 over 5 times 50, which would be 6 over 250. Okay, but what's kind of dangerous is sometimes y'all will be like, oh, I can cross out these zeros. But remember, if you do that, technically you're trying to cross 2 zeros off the bottom and only 1 off the top. That's not allowed. Okay? It's illegal, yes. Okay? So don't do that. But 6 over 250 or leaving it like this. Okay, both of those would be fine. Okay? Your quiz tomorrow is only on related rates. You have a partner. It's open notes. Your homework on related rates is due tomorrow, and then you had your other homework that we did some examples off of.
So this one is due tomorrow?
2 homeworks, yes. That one and related rates.
And this is not due at all?
That is not due at all because we're going to finish it Monday.
These two?
Say bye, Valerie.
Like, read her left.
Bye.